In this video, we will be talking about a couple more of our more common toxic materials and some of their common properties and characteristics. And so we're going to start today by looking at hydrogen sulfide gas. Now, hydrogen sulfide gas is something that you are probably familiar with. You just may not have known that that's what it was. It is the colorless toxic gas that has an odor that's very similar to rotten eggs. And so, where we tend to see it and tend to smell it is in places where there's a significant amount of anaerobic activity going on for bioorganisms. Um, so, where we tend to see that are in things like brackish water, swamps, sewers, um, where you've got decomposition taking place in relatively still water that is not getting a significant amount of oxygen. And so what happens is that those organisms start to do sulfur fixing and they start to um, break down and emit sulfur containing compounds instead of oxygen based compounds. We see this primarily with bacteria. Now, long-term exposure to hydrogen sulfide can deaden your individual sense of smell, can make it actually more difficult for you to smell anything, let alone that. Hydrogen sulfide gas is also a fire risk and an explosive risk if there's a high enough concentration. Now, initially, when you get exposed to hydrogen sulfide gas, H2S, you will experience dizziness and headaches. But if you get exposed to enough of it, you can see people that get unconscious and start to have respiratory paralysis. Um, in air, in the air, inhalation concentrations at or above 1,000 parts per million are considered fatal. That's a fatality due to asphyxiation. Now, again, 1,000 parts per million is a lot. That would be 1,000 milligrams, a full gram of hydrogen sulfide gas for every liter of air that you're breathing. That's a lot. You'd have to have a pretty concentrated sample to do that, but there are some places where that is a possibility, so you do have to be careful. Now, what we also will see is that when certain things thermally decompose, especially natural products, we will see small concentrations that might burn or be emitted as those substances decay. And so we tend to think of things more along the lines of natural materials, leather, wool products. Um, and if those products are heated to a high enough temperature, the decomposition can lead to those hydrogen sulfides coming out. So, under normal circumstances, it's okay to wear a leather belt. It's okay to wear woolen materials or to have wool carpeting in your home. Um, but in the event that there is a fire or that the temperature becomes significantly increased, then we could see possible issues with the production of hydrogen sulfide gas as those substances decompose. Now, hydrogen sulfide gas does have a lot of uses. We can bubble it into water. We can use it to help to produce elemental sulfurs and sulfuric acid. We can bubble it into water and help to process mineral ores. So one of the first processes when we start to work on ores is to get the ores out of the rock. And so if you have a ore, you've got a combination of a lot of different types of oxygenated materials. Your first step would be to dissolve all of those in acid. And then sulfides actually can help to pull out certain types of metals and help them to kind of come out and separate from other types of metals that might be present. We see metallic sulfides, nickel sulfide, molybdenum sulfide are also made in a similar process. And this is a little bit older of a thought, but in electronics that still have television tubes, Um, Hydrogen sulfide is used to make the phosphors that make the television tube. So if you have an old cathode ray tube TV, and there are still some out there, if your TV comes in a box, as opposed to a flat screen, there are phosphors in those, and hydrogen sulfide was used to make those phosphors. Now, when it comes to hydrogen sulfide gas, we note that there are usually fatalities that are associated with exposure, and this is mainly when we have safety practices that are ignored. And so the places where we see these kinds of high exposures are in chemical treatment facilities, refineries, for city workers in sewer systems if they're not using self-contained breathing apparatuses or other kinds of PPE, and other general places where hydrogen sulfide is used or stored. But for the most part, your exposure to hydrogen sulfide gas should be relatively low. And if it is elevated, there are safety protocols in place for how to work with that, how to deal with that from a PPE standpoint. So the last thing that we'll make mention of with hydrogen sulfide is that we know that it can accumulate within confined areas at lethal concentrations. And so one of the safety protocols that I mentioned is the idea of you've got to use appropriate PPE. Fully encapsulated suits, self-contained breathing apparatuses. Depending upon the concentration, at minimum, the self-contained breathing apparatus is recommended. A fully encapsulated suit can also help just in terms of providing you extra protection from the gas itself in terms of getting into your clothes or anything like that. So that is hydrogen sulfide gas. In the next video, we will talk about NOx gases, that is nitrogen oxide gases and the derivatives from those kinds of reactions.